Welcome to The Explainer. Today, we're digging into a really big idea, one that was part of the original vision for the World Wide Web. We're talking about a smarter, more intuitive internet. We're talking about the semantic web.
You know that feeling, right? That frustration. You type something into a search engine and get a flood of results, but none of them are quite right. It feels like you and your computer are speaking completely different languages. But what if that could actually change? What if the web could understand the meaning, the intent behind your words?
To make this real, let's follow a story. So, this is Pete and Lucy. They've just gotten one of those calls you dread. It's from their mom's doctor. The news is stressful. She needs to see a specialist, and she has to start physical therapy on a regular basis. And just like that, they're staring at a mountain of digital busywork. They've got to find a top-rated doctor, one who's also covered by their mom's insurance plan. They need to hunt for available appointments and then, somehow, cross-reference all of that with their own packed schedules to see who can even drive her. With the web as it is today, that's just a nightmare. We're talking a dozen open tabs, endless phone calls, and scribbling notes.
So how could a smarter web possibly solve this? Well, that's what we're here to break down. We'll kick things off with the promise of this smarter web, then dive into the language barrier that holds our current web back. After that, we'll get into the actual toolkit designed to fix it, see what a personal digital agent could do for Pete and Lucy, and finally, zoom out to look at the huge vision behind it all.
To really get how a smarter web could help, we first have to nail down the core problem with the web we use every day. It all comes down to a fundamental language barrier. Why is it that our computers just don't get what we're asking?
You know, the inventor of the web, Tim Berners-Lee, he put it perfectly. The internet was built for human eyeballs. We look at a web page and we just intuitively get it. We understand the context. A computer program, though, it can't. It sees a word like Paris and has no way of knowing if that's a person, a city in France, or a city in Texas. Think of it like this. The current web is a massive, massive library where none of the books have an index. A computer can search for keywords, sure. It can bring you a giant pile of books that all contain the word apple, but it has zero idea which books are about the fruit and which are about the tech company. It can't read the content. It can only match the letters. And this difference, right here, is the absolute heart of the problem. On the left, that's what we see, a nice, clean website for a clinic. We instantly recognize the doctor's name, the hours, the services. But on the right, that's what the computer sees. It's just a mess of formatting tags, like H1 for a headline. It sees the page's structure, but it has no idea what any of it actually means.
All right, so how do we fix this huge communication gap? The solution is something called the Semantic Toolkit, and it's basically a set of technologies designed to weave a layer of meaning right into the web itself. It's about teaching the web to read and even to reason.
The whole process is actually pretty logical. It happens in 3 main layers. First, you start with the most basic thing. You've got to label stuff, so a computer knows what it's even looking at. Then, once things have labels, you can connect them to form simple, machine-readable sentences. And finally, to make sure all the different computer programs are speaking the same language, you create a shared dictionary, a rulebook, so that doctor on one website means the exact same thing as physician on another.
So that first tool, XML, it handles the labeling. We're all used to HTML tags that just say things like, make this text bold. But XML lets you create much smarter tags that describe what the data is. A web developer can make a hidden tag that says doctor name or insurance plan accepted. This gives the raw data some basic, identifiable structure that a program can actually latch onto. But, you know, labels by themselves aren't quite enough. You have to connect them. That's where the next layer, RDF, comes in. It takes those labeled bits of data and uses them to build simple sentences. It arranges information into something called triples, which work just like the subject, verb, and object in a sentence you'd write. And this is what allows a computer to finally understand the relationship between different things.
So here's exactly what one of those triples looks like. The subject is Dr. Hartman, the verb, which is the relationship, is works at, and the object is the Hartman and Strauss Physio Clinic.
All of a sudden, you have this simple logical statement that a machine can easily process and then link up with millions of other statements just like it. Now, to get around all the ambiguity we have in human language, every single concept gets its own unique web address. It's called a URI. You can think of it like a permanent universal ID card for an idea. It makes sure a computer program always knows the precise definition of a term, so it never confuses the address of a building with the address of a speech.
Okay, so we've got labels and we've got sentences. But what if one hospital's database says zip code and another one says postal code? A computer wouldn't know they mean the same thing. And this is where the final crucial piece comes in, the ontology. It's basically a shared dictionary, a universal rulebook that different programs can use to find common ground.
This is the key that lets completely different systems work together. An ontology can officially declare that one database's zip code is the exact same concept as another's postal code. And that's what lets independent programs pull information from tons of different sources and do it seamlessly and accurately. So we have the tools: labels, sentences, and a shared dictionary. Now let's see what happens when we put it all together. This gets us to the real payoff, this idea of a personal digital agent that can actually do the reasoning for you.
Just look at the difference. On the left is a search today. You know, that messy list of links you have to sort through yourself. But on the right, that's a semantic search. Your agent program understands the relationships between therapist and insurance and schedule. It does all the work for you, and what it gives back is a single, precise, actionable answer. So let's bring it back to Pete and Lucy. Can you imagine what this would have meant for them? Their agent, running on the semantic web, could have just done all the heavy lifting. It would have understood the doctor's prescription, then filtered providers by their rating, their location, and their insurance plan. Then it would cross-reference all of that with Pete and Lucy's own calendars. If Pete added a new rule, like it has to be after 5 p.m., the agent would just rerun the search instantly. This isn't just searching anymore. This is automated reasoning.
But what about trust? I mean, how do you know the information is any good? Well, the system is designed with that in mind. Agents can actually demand proofs for the information they get, and they can use digital signatures to verify that the data really is coming from a legitimate source, like an insurance company's server or a doctor's office. But the vision here is so much bigger than just smarter searches. It's really about creating a web that connects everything, and I mean everything, even things beyond our screens. The idea extends right into the physical world around us. Imagine your phone rings. It could automatically broadcast a message out into the room that any and all nearby devices that understand the concept of volume control should turn themselves down. Not just your specific smart speaker, but any device that shares that common understanding.
When you get right down to it, this isn't just about convenience. The truly grand vision is to create a whole new class of tools for humanity. By building this universal web of linked concepts, we could let software agents analyze and find patterns in the vast ocean of human knowledge in ways we can't even really imagine yet.
And that leaves us with a pretty powerful question to chew on. This technology is designed to intelligently connect all recorded human knowledge, all of it. If we can actually achieve that, what are the big challenges, the grand problems in science, in medicine, in our society that we would finally be equipped to solve?